Welcome to the WHONET training course. This course has been prepared by the WHO Collaborating Center for Surveillance of Antimicrobial Resistance, based with the Division of Infectious Diseases at the Brigham and Women's Hospital in Boston. The course consists of 6 modules. The first module, Introduction to WHONET, covers the vision and objectives of the WHONET project and its use around the world. You will learn how to install WHONET, and you become familiar with the WHONET main menu. In Module 2, you will learn how to create a new laboratory configuration with important details about your laboratory, including the laboratory name, the list of antibiotics that you test, specimen collection locations, and whether your laboratory tests specimens predominantly of human, animal, food, or environmental origin. In Module 3, you will learn how to enter data manually into WHONET, edit results, and generate clinical reports that can be shared with specimen collectors and healthcare providers. Modules 4 through 6 cover different aspects of the WHONET data analysis features. In Module 1, Introduction to WHONET, there are 3 sections. What is WHONET? How do you download and install the software? And a review of the WHONET main menu. Section A, what is WHONET? WHONET is a widely used free software developed for the management and analysis of microbiology laboratory data to support local, national, regional, and global activities to track and contain infectious diseases with a special focus on antimicrobial resistance. WHONET is a desktop software developed for Microsoft Windows. 2 new versions of WHONET are in development. 1, web-based data entry, and 2, a version compatible with Mac and Linux. The work that eventually became WHONET began in the 1960s. Recognizing the clinical impact of rising resistance on clinical outcomes around the world, Drs. Kirby, Bauer, Sherris, and Turk in Seattle developed the disk diffusion method as a practical method to be used by routine microbiology laboratories to support day-to-day therapy decisions by healthcare providers. One individual trained under Dr. Kirby and Sherris was Dr. Thomas O'Brien, based in Boston. Dr. O'Brien appreciated the disk diffusion test not only from a clinical perspective, but also from an epidemiological perspective. He understood that disk diffusion zone diameters could be analyzed to recognize and track distinct and evolving microbial subpopulations and changing threats in antimicrobial resistance. The name WHONET was given to the software in 1989, but the early programming work led by Dr. O'Brien started on mainframe computers in the 1960s. Over the years, Dr. O'Brien developed a clear vision. He recognized that human health, animal health, food and environmental microbiology laboratories worldwide generate a detailed window into evolving microbial populations in real time to support day-to-day clinical care needs. But he also realized that these data remain underutilized to support public health policy and resistance containment interventions. His realization was that the use of a common software could and should support local, national, regional, and global collaborations and analyses to support 2 broad objectives. 1, containment of infections and antimicrobial resistance. This would include the recognition, tracking, and containment of emerging threats in real time, treatment guidelines, and antimicrobial stewardship programs, public health awareness, advocacy, policy, and interventions, and basic science, clinical, and operational research. And secondly, continuous quality improvement in laboratory practices and diagnostic stewardship. A wide range of coordinated activities by multiple stakeholders needs to be instituted for the effective containment of antimicrobial resistance. Consequently, surveillance programs must serve multiple objectives. These would include policy and advocacy development, tracking the evolving epidemiology of resistant microbes, the initiation and evaluation of resistance containment interventions, and strengthening laboratory and epidemiological capacity. There are also distinct responsibilities and actions that need to be taken at local, national, regional, and global levels. So data collection, analysis, interpretation, and action are needed at each of these levels. We can also view the objectives provided on the previous slide in a simplified way. Two fundamental objectives are: one, the use of local data to support local action, and two, the promotion of national, regional, and global collaborations. In this way, we can highlight the importance of local level, both for real-time confirmation and response to new threats, and also for ensuring the long-term sustainability of surveillance initiatives at all levels. If there is insufficient value in surveillance activities to local data generators, this can decrease the likelihood that surveillance collaborations will be able to continue. WHONET data generally come from microbiology laboratories, which may include human and animal health laboratories and food and environmental laboratories. WHONET can be used for data from routine daily operations, as well as from special surveys and research projects. While most laboratories use WHONET to store data on bacterial and fungal results, but it can also be utilized for results such as no growth and normal flora and viruses. It is also possible to enter clinical data into WHONET, such as diagnoses, risk factors, therapies, and outcomes. Such information is usually not available routinely to microbiology laboratories, but they can often be collected in a limited way for special studies. While the data come from the microbiology laboratory, there's a much larger number of potential users who may have interest in the results of data analysis. This would include laboratory staff, infectious disease and infection control teams, human and animal health clinicians, pharmacies, food producers, environmental scientists, policymakers, researchers, and others. Consequently, it is often useful to teach data entry with WHONET to laboratory staff, but it is also very useful to teach data analysis and interpretation to a much larger number of healthcare and other professionals. After you install WHONET, you will see that the software has three core modules: laboratory configuration, data entry, and data analysis. Data entry offers two options: manual data entry and importing data with backlink, and three approaches to data analysis: interactive analysis, where you select the analysis parameters; convenient quick analyses, where these data have been defined previously; and reporting to public health initiatives such as WHO GLASS and FAO Inform. On the next slides, you will see a few screens which highlight some of the key features in each of these modules. Laboratory configuration. In this module, you define your country, your laboratory name, and a short code for the laboratory. You indicate whether you predominantly collect samples from the human, animal, food, or environmental sectors. When you click on antibiotics, you choose your antibiotics, your test guidelines, such as CLSI and UCAST, and your test methods. You can also define antibiotic panels to indicate which antibiotics are tested for each group of organisms. When you click on locations, you can indicate the sample collection locations. These can include human locations like a hospital ward or outpatient clinic, or animal locations such as a farm or a veterinary clinic. Locations for food samples could include markets and restaurants, while environmental samples can come from river water or wastewater. Under data fields, WHONET offers a list of data fields such as first name, last name, animal species, specimen type, water type, organism, and beta-lactamase result. By default, WHONET defines standard list of data fields for samples of human, animal, food, and environmental origin. But you also have the ability to add additional questions to this list that are of interest for your organization, such as gram stain, physician name, or diagnoses. You can also remove questions that are not relevant, such as patient name for animal isolates or date of birth for food samples. In alerts, WHONET offers over 200 microbiological alerts categorized as important species, important resistance, quality control, and therapy alert. These are categorized as high priority, medium priority, and low priority. You can activate and disactivate these rules included with WHONET. You can also create new alerts according to your local and national reporting needs. When you finish the laboratory configuration, you click on Save. You are then ready to proceed with data entry and data analysis. You will learn more about laboratory configuration in Module 2 of this course. This slide shows an example of manual data entry. You can choose the origin of the sample, human, animal, food, or environmental. You can indicate information such as the patient's name and date of birth, or the animal species, or the type of food or water. You can indicate the location of sample collection. This could be a medical clinic or a farm or a market or a river. You enter specimen details such as specimen date, specimen type, specimen number, and organism details such as the name of the microbial species, serotype, and beta-lactamase result. As mentioned in the discussion of laboratory configuration, WHONET offers standard list of data fields, but you have the ability to add and remove questions to match your local data management and project needs. For the antibiotic results, you have the choice between entering dish diffusion, MIC, and gradient diffusion results, such as the e-test. WHONET can provide interpretations according to the human and veterinary guidelines of CLSI and UCAST. Other useful options on the screen include Save Isolate, View Database, Print, and Exit. You will learn more about data entry in Module 2 of this course. The previous slide presented manual data entry into WHONET. However, if you already have a data management system, it is usually possible to import your data into WHONET using the backlink software, which avoids the needs for double data entry. Most laboratories in the world, especially in medium and high-income countries, already have computer systems for managing microbiology data. These may be simple systems, such as Microsoft Excel, or it may be a laboratory instrument, such as Vitek, Microscan, Phoenix, or Sensititer. It can also be a local or commercial laboratory information system. On the one hand, these diverse systems are an obstacle because they are not directly compatible with each other. But on the other hand, they are also an opportunity. Laboratory staff have taken the time and effort to store the data in a computer system. So the goal of Backlink is the conversion of data from these existing incompatible systems into standardized WHONET files with common structures and common codes to facilitate data sharing and analysis. A core principle is interoperability, ensuring that multiple systems can work together smoothly and efficiently, taking advantage of the strengths and features of each system. Data analysis can proceed in one of two ways in WHONET: interactive analysis, which is shown on this slide, and quick analysis, which will be covered later. In interactive analysis, you choose precisely the analysis that you would like. You choose the analysis type, such as alerts, statistics, graphs, and charts. You choose the organisms, and you can choose the data files. And then you can begin your analysis. The options circled in red are required before you begin the analysis. Besides those required questions, there are additional options circled in orange. For example, if you click on isolates, you can define selection criteria, such as specimen type equals urine, or animal type equals chicken, or imipenem equals resistant. If you click on one per patient, you will see a number of options, such as selecting only the first isolate per patient per species for an analysis. You can output results to the screen, or to Microsoft Excel, or to Microsoft Access, or to other software options. When you have defined all of your analysis criteria, then you click on Begin Analysis to see the results. If you intend to repeat the analysis next week or next month, there is a useful option at the bottom of the screen called Macro. This option allows you to save the analysis parameters into a WHONET macro to facilitate repetitive analyses in the future. This slide presents some examples of the analysis features offered by WHONET. The first figure is labeled %RIS and histograms. You can see the percentage of isolates that are resistant, intermediate, and susceptible presented in the table. You also see a graph with the distribution of zone diameters for Escherichia coli and gentamicin, where the susceptible bacteria appear to the right of the red lines and the resistant bacteria appear to the left. The next figure is a scatter plot, comparing the result of two antibiotics, In this example, gentamicin and amikacin for Klebsiella pneumonia. This kind of presentation is valuable for the pharmacy in examining issues of cross-resistance. This is helpful in determining recommendations for first-line therapy and second-line therapy. The final figure in the first row demonstrates the analysis feature called resistance profiles, which provides a study of multi-drug resistance. The graph illustrates the number of isolates of Escherichia coli in different facilities over time that were found to be resistant to ceftriaxone and ciprofloxacin, but susceptible to ceftazidime. The tracking of organisms according to resistance profile in time and space is of great value for the early and automated detection of possible disease outbreaks. The study of multi-drug resistance also has relevance in the development of therapy guidelines and the selection of treatment alternatives. The middle figure, the figure in the bottom left, illustrates the use of microbiology alerts shown in red to notify laboratory and infectious disease staff for results of public health or clinical importance, as well as infrequent and unlikely findings, which may suggest an error in test performance. The final figure demonstrates statistical alerts for the detection of possible outbreaks in the community or outpatient setting. The statistical alerts are possible through the integration of the free SATscan software in WHONET. SATscan stands for Space and Time Scan Analysis. In this graph, the red bars represent a statistically significant clustering of patients with Shigella sonnei, which are non-susceptible to the antibiotic SXT, known as trimethoprim sulfamethoxazole. In the feature called Quick Analysis, WHONET offers a number of standard reports. The WHONET team has created several multi-component reports that are available to you. You also have the ability to create your own user-defined reports to match your reporting needs and preferences. The advantage of these reports is that you receive a lot of valuable information very easily and quickly with little work. This slide demonstrates some of the options for quick analysis reports. The three most common choices for output are Screen, Excel, and Word. If you select Screen, WHONET will show a series of interactive outputs, such as organism by laboratory, organism by age group, organism by specimen type, or gram-positive antibiogram and gram-negative antibiogram. For Excel, you will see the same results, but with Excel formatting and Excel graphs on consecutive sheets. If you select Word, the output will focus on the presentation of priority results, along with descriptive and educational text in a format suitable for sharing with your colleagues and stakeholders. The images at the bottom highlight two examples of interoperability within WHONET Quick Analysis. One, export to the AMAS report template developed by the Mahidol Tropical Research Medical Unit. And two, export to the DHIS2 Public Health Surveillance Platform. As mentioned in the discussion of data imports with backlink, the principle of interoperability is very important to ensure efficiency, sustainability, and impact of collaborative efforts. This also is true in data exports. WHONET has the ability to export to a number of public health reporting systems, such as GLASS modules, including GLASS AMR, GLASS Fungi, GLASS eGASP, DHIS2, AMAS, EARSnet, CSER, OSIARSnet, MicroReact, and others. WHONET was initially created over 30 years ago for human health. And in 2001, the WHONET team began to introduce a number of modifications to make the software more suitable for use outside of the human health sector. These were done in collaboration with FAO, WHO, the World Organization for Animal Health, the U.S. Department of Agriculture, the U.S. Food and Drug Administration, and many others. Examples of modifications have been expanding the number of animal species, production types, food types, water types, pathogens, antimicrobials, specimen types, and alerts. WHONET also includes data entry and report templates matching FAO and INFARM protocols. WHONET includes the published CLSI and UCAST clinical breakpoints for samples of human and animal origin, as well as the UCAST epidemiological cutoff values. When you install WHONET, WHONET provides you with two sample databases which you can utilize to practice the WHONET analysis features. One of those is a data set of 622 human health isolates. The second database is 400 isolates, including results from 100 human samples, 100 animal samples, 100 food samples, and 100 environmental samples. In summary, WHONET is a free software widely used around the world for the surveillance of evolving microbial populations. One important focus is, of course, the annual surveillance of priority resistance trends. This is crucial to support awareness, treatment guidelines, and advocacy. But during this course, you will see that there are many additional options that can be of even greater value in two areas. One, the real-time recognition, notification, and containment of emerging threats, including new resistance and possible outbreaks. And two, continuous quality improvement in laboratory testing, capacity, and data quality through notifications of unlikely results and ongoing feedback on appropriateness of test practices. Section B. We will now move on to the download and installation of the WHONET software. If you go to the web page, whonet.org, you will see the main menu for the website at the top with a number of options. Software, which provides links to all of the WHONET software utilities. Training Center, where you will find links for this course and other training materials. Webinars, with recordings and presentations from the WHONET webinar series. The discussion forum, where you can join the WHONET community. In the public area of the website, you can ask questions about the WHONET and backlink softwares and post announcements about your activities. You can also create private discussion areas for you and network collaborators. About. This link provides some background about WHONET and a brief video. And finally, Contact. You can find the contact details for the WHONET team, and you can also join the WHONET mailing list. Here on this home page, you will see two links at the bottom that you can use to download WHONET. We'll take a closer look at this section on the next slide. The WHONET team provides two versions of the installation package, a 32-bit version and a 64-bit version. Fortunately for the majority of WHONET users, it does not usually matter which version you choose. Both versions should work well for most computers. However, for some computers, there can be problems of incompatibility when you try to export results from WHONET to Microsoft Excel or to Microsoft Word. For these computers, choosing the correct version of WHONET will help to decrease incompatibility problems. For these computers, if a 32-bit version of Microsoft Office is installed, then we would recommend installation of the 32-bit version of WHONET. Similarly, if a 64-bit version of Microsoft Office is installed, then we would recommend installation of the 64-bit version of WHONET. Newer computers usually have a 64-bit version of Microsoft Office installed, but this is not always the case. How do you know which version of Office you have installed? The steps are very simple. Step 1. Open any Microsoft product, such as Microsoft Excel or Microsoft Word. On the vertical menu, you should see an option called Account. If you see this option, then click on Account and proceed to the next step. However, if you do not see Account, then this would suggest that you have an older 32-bit version of WHONET, so you should download and install the 32-bit version of WHONET. Step 3. If you can click on Account, you will see the option About Excel or About Word. Click on this option. Step 4. On the final screen, you will see a message indicating which version of Microsoft Office is installed. In the example on the slide, you will see that a 64-bit version of Microsoft Office is installed. Once you determine your version of Microsoft Office, click on the link to download the 32-bit or the 64-bit version of WHONET. The web page will then begin to download the installation package. When the download is complete, you should see an option that says Open or Run. Depending on your version of Windows, this could be in the lower left area of the screen or in the upper right. If you do not see the installation package on your screen, you can usually find it in your folder for downloads. Click on the file that you downloaded, and this should start the installation process. Step 1. This is the first screen. Click Install. Step 2. On some computers, you may receive the below question. Do you want to allow the app to make changes to your device? If you receive this question, then click Yes. Step 3. On this slide, the installation software is welcoming you to the setup wizard. Click Next to continue. Step 4. On this slide, you will see that the installation software will install WHONET to the location C:\WHONET on your local hard drive. If you wish to put WHONET into this particular folder, simply click on Next. However, you may wish to change this to a different location on your local hard drive, or you may wish to install WHONET to a network drive, such as an H drive or a Z drive. This is the final step. Click on Install and the installation will begin. That completes the installation. Click on Finish to close the installation software. The installation software will then confirm that the installation has successfully completed. Click on Close. If the preceding steps went well, you should now see two new icons on your desktop for WHONET and Backlink. Double-click on the WHONET icon, and that should open the WHONET software as you see here. So if you see the screen, congratulations, you have successfully installed WHONET. If you do encounter installation problems, here are a few suggestions. Try the process again. Re-download the software, reinstall the software, maybe reboot the computer and try again. Or contact your IT team for assistance. In many organizations, typical staff members are not permitted to install software without the approval and assistance from the IT department. These restrictions are introduced to decrease the risk of viruses and incompatibility issues. Or you can try a different computer to see if it works on another computer in the office. Or if you are still unable to install WHONET, then please contact the WHONET team at help@whonet.org. Windows was developed to be used on Microsoft Windows. Fortunately, many users have successfully installed WHONET on computers with Mac OS. There are a number of technologies that can support this, including the creation of a Windows partition onto the computer's hard drive, the installation of a Microsoft Windows virtual machine, or the installation of a Windows emulation software. To learn about these approaches, you can perform a web search, how do I install a Windows application on a Mac? Or you can reach out to the WHONET team at help@whonet.org. The WHONET team has made significant progress on a version of WHONET that could be run directly on a Mac and Unix computers, but there is no estimate on when this will become available for testing. Section C. We now move on to a discussion of the features available on the WHONET main menu. When you begin WHONET, you will see this initial screen, which includes a list of laboratories currently installed on this computer. As you can see here, when you install WHONET, you will see a single laboratory called the WHO Test Laboratory, which you can use for practice. If you're responsible for data from a single laboratory, you can create a new laboratory configuration for the laboratory. Or if you are a national data manager, eventually you might have 10 or 50 or more laboratories listed. On the screen, you specifically see a list of laboratory configurations that exist in the WHONET folder, as indicated at the bottom of the screen. Alternatively, you can use the Browse option if you wish to save the laboratory configurations to a different location, such as a network drive, so that many staff can share the same laboratory lists. You will see a number of features related to the management of your laboratory configurations. These will be covered in greater detail in Module 2 on WHONET laboratory configuration. The key features here are New Laboratory, Open Laboratory for purposes of data entry or data analysis, Modified Laboratory to make changes in the laboratory details, such as the list of antibiotics, locations, and data fields, Copy Laboratory, and Delete Laboratory. The default language is English. In the next slide, you will see how to change the language. I will now click on Language and Date Formats and move on to the next slide. On this screen, you will see that English is selected on the first image and Spanish on the second image. The word OK has changed to aceptar. After you click on Aceptar, you will return to the previous screen, and all of the screens and outputs in WHONET will appear in English. The screen now appears in Spanish. For purposes of this lesson, I will now click on Idiomas y Fechas, which means language and dates in Spanish, and select English again. Then the software messages will again appear in English. WHONET currently includes 53 supported languages. Many of these translations were created with Amazon Web Services. Amazon Web Services and Google Translate are excellent language translators for most languages. However, they are not perfect, and there are often mistakes and suboptimal translations that can be improved by native speakers. If you would like to help the WHONET team correct and improve the translations, please let us know at help@whonet.org. We have now returned to the WHONET main screen in English with a list of laboratories. To proceed with a review of other features on the WHONET main screen, I will choose the WHO Test Laboratory and click on Open Laboratory. You will now see the four options on the WHONET main screen: File, Data Entry, Data Analysis, and Help. If you click on the File menu, you will see some features that have already been mentioned, such as New Laboratory, Open Laboratory, Modify Laboratory, and Language and Dates. The options under Data Entry will be covered in Module 3, while the Data Analysis options will be covered in Modules 4, 5, and 6. The slide shows three options available on the Help screen: Documentation, Check for Updates, and About. If you click on Documentation, you will see the list of tutorials that you can use to learn more about WHONET. You can then click on the X to close this window and return to WHONET. These documents are also available in the Training Center on the WHONET website. If you click on About, you will see the contact details for the WHONET team and the website for WHO GLASS. This screen also provides useful technical details. For example, in the screen, you will see that a 64-bit version of WHONET from October 2023 is installed in the WHONET folder. You can then click on OK to close this window and return to the main menu. Thank you for monitoring Module 1. The training course will continue with Module 2 on laboratory configuration. Thank you for your time.